landed in Barcelona, stayed there for a few hours, and then took the train to Valencia. And the reason why I had to do that was because I actually had a speaking session at a conference called the Cloud Native Rejects Conference. It's a conference that if you didn't make it to Kubecon because your talk was rejected or you missed the deadline, it's another opportunity to just drop a submission there. Cloud Native Rejects is a very relaxed kind of conference. It's a lot more smaller. It's a lot more intimate. And what you'll find is there are a lot of like contributors, maintainers, and even practitioners that'll come out there as well to either speak or just attend. So it was actually a really great thing. And that, Cloud Native Rejects is actually going to be available as well for Kubecon NA. So since, maybe you might have missed your conference talk or like missed the submission there, it's an opportunity for you to submit to Cloud Native Rejects as well. So I started my journey there, and it was a great time, just doing the pre-con before Cloud Native Con. But the whole KubeCon conference itself, like there were around 18,000 plus attendees. A good chunk of them were on site, like about 7,000 of them, and you would gradually, if you were there, you would gradually see from Monday to Wednesday how that audience just started growing. So Monday and Tuesday were all the adjacent conferences, so like Service Mesh Con and eBPF Con and Telco Day and all these other conferences, GitOps Con, I think, as well. And so you would see all of these attendees there doing their thing and just like shifting around. And that's like when I started to get to find a lot of the folks that I've been, chatting with or communicating with on Twitter. And then we started doing the whole selfie thing, and yeah, it was pretty fun. But yeah, there were a lot of people in person there. We were, the majority of us were working really hard to make sure that we were all masked up. I think, the only times people were unmasked were if they were eating or drinking, and that's pretty much it, or outside of the actual facility. So it was a pretty good vibe. Towards the end of the conference, we started getting notifications that individuals were testing positive for COVID, but we got a report. Or actually got an email yesterday that they basically determined that only about 1.2% of the entire attendee population caught COVID, well, as far as we know, and they were able to track that through various means. So from a safety standpoint, I think they did a great job. There were some things I was a little concerned about, but overall, like for an in-person conference after quite a while, I enjoyed it. So here are some stats. I'm not going to read them out to you, but I think the one that sticks out is that there were about 65% new first timers showing up on site. And that's very interesting because I think a lot of developers and a lot of practitioners or operators are starting to realize that there's a lot of value going to these conferences, not only for the talks and the stories that they get to see, but also for the people and the networking that they get to do through the hallway tracks. So there were a lot of different sessions. In fact, if you go hit the playlist at the link there, you'll see all the sessions have been recorded and they're available for consumption. I mean, there are almost 500 sessions. I don't know how anyone's going to have the time to go through all of them. I might be able to do like 10 and only in the focus area that I play in, but hey, there's a lot of information out there, a lot of great stories. But there were like some key focus areas that I started to pick up on. And it really kind of started with the keynote. In the keynote there was a very strong emphasis on practicing empathy and kindness, because I think like for the last 2 years or 3 years now, I think we're going almost, everyone's been stressed out, a lot of pent up emotion, a lot of work that just gets transacted with on a daily basis by so many different people, a lot of touch points, that we forget like that element of kindness. And so Van and Priyanka were up there, well, Van wasn't physically there, but he was there remotely, just talking about how we really need to practice a lot more kindness and empathy. And that was an interesting approach there, because I get it, like there's a lot that goes on, But I think, we kind of need to do, we kind of need to just, spend that moment there and always understand what might be going on at the other end, before we start to, make our next move there. So there are a lot of key areas that I noticed and a lot of key focus, at Kubecon, but more specifically, there was an emphasis on how developer experience and creating a platform for developers, was crucially important. And that's just because for the longest time, we've been creating platforms for developers to consume. And we haven't really been taking in a lot of their feedback up until recently. And so the whole mindset here is, how do we take their feedback and make sure that we're building something for them that actually they want to consume? They feel that they can use daily with their tooling, with the way they build their apps and whatnot. There was another focus on community, right? Coming together to collaborate, to solve problems, to mentor each other and build each other up. And then there was actually a very interesting panel on burnout and recovery by Divya Mohan, which I actually was just going through yesterday along with Julia's burnout talk. And so it's interesting to see that this is becoming a very crucial area within the whole cloud native and even Kubernetes community, because quite honestly, like we've been grinding super hard lately, and we tend to forget about taking care of ourselves. And I think that's back and focus a little bit on. Another key area that I started to pick up on, or that I actually noticed that people were gravitating towards, was the networking stack and technologies that we use when it comes to Kubernetes. And so the Cilium CNI was pretty much a highlight, and I'll mention something about what Solo did very shortly. But the Cilium CNI, for those that aren't familiar with it, is a container networking interface for Kubernetes that allows you to network your pods together and do some very interesting network policy against them as well. And followed by that, eBPF was another big thing. People wanted to know more about it. And so if you happen to be at the floor or on the floor there, the Isovalent booth was actually swarming with very, very interested and curious folks out there who wanted to know more about the direction of eBPF. And interestingly enough, like Solo got into that game as well. And so people were coming up to the Solo booth and talking a little bit more about that. Service mesh. So service mesh was actually a very interesting thing that I started to see, where people were talking about it. Like I would just walk around and I would just overhear people talking about service mesh, Linkerd versus Istio, and where things are going. And so part of that was the whole announcement of Istio being donated to the CNCF from Google. And why we see that is as important is that Istio has established itself as a very highly capable service mesh technology. A lot of massive companies are using it. Google backs it. Solo, the company I work for, we heavily invest in building on top of Istio and other technologies as well. But from a consumption standpoint, it seems to be the most consumed service mesh out there. Another very interesting pattern was the whole conversation around multi-cloud and multi-cluster. So Kubernetes has gotten to this point where it's so stable, or pretty darn stable, that it's also become boring. And because it's become boring, people are starting to realize what's next. And so they're transforming their app patterns to be very multi-cluster oriented, or multi-cloud oriented as well. And so that was another interesting piece where we started to see like elements of companies out there pushing out abstraction platforms to manage multiple instances of cloud or Kubernetes. Another key area of focus is around GitOps and Argo CD. So the GitOps Con, for example, there was a lot of information out there around GitOps and methodologies and different stories around it. And Argo was just right behind that. So a lot of sessions were using Argo. Backstage as a developer portal was another very interesting area altogether, in the sense that Backstage has been open source for a while. Backstage has has been open sourced by Spotify, but the developer portal is highly customizable. And so I saw a lot of people attending a lot of their sessions as well. Those rooms were packed. SigStore and secure supply chain was another very interesting area. Machine learning too, and then FinOps and Kubernetes cost control seem to be very recurring themes throughout the conference. That being said, so I mentioned Solo had something to do with Cilium. So we've actually announced that we're going to contribute to the Cilium. So you should see some more things from us very soon. I actually plan to talk a little bit more about Cilium, and I'm doing a stream on Friday about how to get going with Cilium and messing around with policies and BGP. And then this is just a quick visual of what was going on there at the actual conference. And I also had a video to share, and unfortunately the video didn't get loaded into.
I've shared this. It should be good. People can see it in the Slack and in this chat room as well. So that's
yeah. So yeah, the video is there. What I can quickly do is I should be able to drop it in. Insert video, and it should show up. Let's see if that works. There we go. Oops. I'll just mute it, but you can kind of get a sense of what's going on in Valencia. And
how was the parties? Like, was it?
Yeah. So the parties were kind of interesting. The parties themselves, there were actually a number of them. I didn't actually go to the very last one, but there was the booth crawl that was going on within the actual pavilions. So you would see a lot of people just walking up to booths and just walking around with beers and stuff. And there were actually some adjacent parties that went on at Kubecon that were like hosted by Gitpod, another one that was hosted by Microsoft, another one that was hosted by Amazon AWS. We hosted one as well. There were just so many different parties, and quite honestly, there was one night I actually ended up having to go to 3, and that was such a journey because, like in Spain, it's not easy to find a taxi, and so you're kind of like walking a bit before you actually find something. And once you do, okay, great. But then by the time you get there, you're literally like in there for 10, 15 minutes. And then I just bolted off to the next party. But I hope KubeCon NA isn't as chaotic in terms of getting around, because it'll be, we'll have Uber and Lyft and all that stuff. So yeah.
Well, thanks a lot. I mean, like for us, we didn't go there. Like I tried to attend every single one, but like pretty much one of the first ones I couldn't go. Like I feel sad a bit, but I'm hoping that we can make it for the next one, hopefully. And I just want to be mindful of time, and I'm gonna switch the mic to Aaron. But like Marino, thanks a lot and welcome to our team. Hope we can chat more. And like, there's a lot of announcements were at the KubeCon as well, but I don't think we have time to cover them all. So
too many. Yeah. Thank you.
All right. So, Aaron, do you want to go ahead and get started? I think I had a slide about you, but I'm sure you have your slides as well. So I'll just.
Thank you very much. I'll share my screen. We'll whiz through it's about me efficiently. That's good.
All right.
Well, thank you very much, everyone. It's great to be here today. Really appreciate it. Canada CNCF Eastern Canada Meetup. Today, I wanted to just give you a brief introduction to KEDA and Kubernetes event-driven autoscaling. I'm sure there's a number of folks here who use KEDA already. I'd love to hear more from you and to hear what people are hacking on. And all HTTP add-on. So first and foremost, who am I? I'm Aaron Wislang. I'm a cloud advocate at Microsoft. I focus on open source engineering, cloud native, and Go. You can find me on Twitter at AS_W, and all my other links, etc., at aaronmsft.com. So let's dive in very, very quickly. So what is KEDA? KEDA is Kubernetes event-driven autoscaling, and it enables you to scale workloads on your Kubernetes cluster according to various sorts of events. So it's to scale workloads out to a large number of containers. It also allows you to scale workloads to 0, which is one of its key differentiators compared to other scaling approaches, such as the horizontal pod autoscaler, etc. You can KEDA on GitHub and KEDA.sh. It was originally announced in May 2019 by ourselves and Red Hat. It was initiated by a group inside our serverless compute inside of Azure, built to initially framework we could run our serverless open source service runtime on top of Kubernetes and bring that so people can run it anywhere. And we donated it to the CNCF in March 2020. It became a sandbox project, and it to 2.0, which added new features, including different scalars, which we'll go on to and talk about in a little bit. And then it graduated to a CNCF incubating project in August 2021. It's now at it's very open, it's cloud agnostic, vendor neutral, and community first. So it's a great project to get involved in, and it integrates with many different open source platforms. It's specific cloud offerings or anything like that. So it's a true community first CNCF project. And I'd look a little bit into the architecture of KEDA, just so we know the moving parts that we're dealing with here. So KEDA is implemented, it uses a CID called a scaled object. So it introduces this concept to your cluster. And it has a scaler which monitors external trigger sources for events. And it pairs that with a metrics to horizontal pod order. So it uses the native Kubernetes horizontal pod autoscaler to scale your workload from 1 to however many containers or replicas you require for the workload according to your scaled object. And it also uses the controller inside of KEDA to scale your workload to 0 when there are no more events coming in or according to specific rules around being idle or something like that. So it's fully utilizing Kubernetes itself. It doesn't seek to replicate all of those, and it integrates with all of this. Yeah. And that's the basic architecture, and it's very focused on this particular. So what sort of resources does KEDA scale? So it can scale deployments. Deployments are what most people probably scale by default. It can also scale stateful sets, which are quite useful if you're scaling out something which hard out or access events in a pattern. We'll talk about later, maybe when maybe you're looking at a blob storage account or something like that, and you want each to be working on one particular partition. There's lots of ways to do that. Scale custom resources, anything with a scale sub resource that KEDA can manage, or the horizontal pod autoscaler can manage. It can scale for you. So these may not necessarily be containers. You may be resource, which in turn is controlling up in the real world at the edge or that. And finally, it can also scale jobs. So in addition to the CID for the scaled object, we have this concept of a scaled job, which enables us to scale job work, sort of a one-to-one relationship between the events and the job workers that need to be processing that. That could be long-running video encoding tasks or something like that. And you don't want those to be interrupted or scaled down before they're finished, be in a deployment or a stateful set. So those are the resources that KEDA will scale. And this is what a KEDA scaled object looks like. So this is what you'll be dealing with inside of your cluster. We have the KEDA.sh names. We have a target, the workload that we're looking to scale, the could be a deployment scale, etc. And we have the configuration. So I'll try not to drown you with YAML. You'll see quite a few scaled objects and bits and feel free to ask any questions away. I'd love to hear more if people are using KEDA already or have questions about how it operates. But you see here we have things like a polling interval, so it will poll. It has things like cooldown period, so when it does a scaling operation, it will wait a certain period before scaling back down or performing another scaling operation. Things like an idle replica count. When it's idle, how many replicas do we want? Replica count, which can be 0, and max replica count, which you can use. And there's some great documentation for KEDA on KEDA.sh. It's very approachable in that regard. This is what a scaled job looks like. So if we're working with jobs, it's all fairly similar. Parallelism, the completions, the deadline for the job to complete, things like backoffs, the job template, but also other things like our job history limit. Sorry, our job history limit, where it will go and your jobs once they are completed, so you're not sort of polluting your cluster with all of those things. And if you have a look here, we also have a failed job history limit. So if you need to go back and debug failed jobs, it'll go through and it'll do all of that for you. So all of the powerful, you a lot of knobs and dials which you can use to manage your scaling of these kind of workloads. A lot of times we can think about doing these things in a custom way, and I think I'll just whip up some code to do this, or anything from a bash script to my own Kubernetes. But this has a lot of battle-tested sort of things baked in into its approach. And these are the scalars that KEDA supports today. So we have over 50 different scalars. You'll see a lot of open source projects here, and Apache Kafka, Cassandra, Prometheus, Nats. These are all fantastic ways to utilize KEDA anywhere on premises, on a Raspberry Pi, all of those kind of things. There are native Kubernetes options like CPU and memory, but we also have some, obviously the cloud provider based ones. We have queues and things, streams and all of those things across Azure and AWS and GCP. But we also have a little bit more interesting. We have a cron scaler, for example, which allows you to scale according to specific times. We have things like a Postgres scaler. So Postgres is not natively used for queues and things like that. Stuff like a external push and external scalars, which allow us to extend KEDA. So we're going to talk about that briefly as well. So this is how people create a scalar. And we talk about all these integration points. KEDA is and you only need to implement one interface called the scalar interface. And the most important part of the interface is the get metrics function here. If you can implement a get metrics and you can scale based on something, you can probably build your own scalar. And the way it decides how to scale the number of replicas is via this very simple approach here, where it takes the current metric value divided by the desired metric value, and multiplies that by and that's how it defines how many replicas it wants. So it's fairly simple, fairly straightforward to understand and reason about, and it really is quite approachable to build your own scalar. And there are two different types of scalars. One of them is a scalar where you can go out and you can get metrics from a, and the other is a push scalar. Events can stream into KEDA and then scale out your workload with lower latency. If you're even slightly interested in this kind of thing, I would encourage, because you might come up with a use case and have an idea for a scalar, and it could be very, very powerful. And I'd love to help anybody who is working in this area and is interested in building something in this space. I also work on the KEDA project, and I'd love to help people and get them hacking. One of the scalars that I just want to highlight here that are outside the usual kind of event-driven workflow are things like the cron scalar. This is quite useful, not running a workload at a specific time, like a cron job, but for things like scaling up your application during specific time periods. You might be have your Kubernetes cluster or your web service under load at a specific time of clusters in different regions, and say, hey, I need to scale up according to this region. Or maybe I'm a company that sells sandwiches and we have a lunchtime rush, and we need to know that every day during peak hours we need enough order processing capability scale down without having to try to auto scale our clusters in a more, or our workloads in a perhaps more brittle way that may drop more requests or be harder to reason about operationally. We have another favorite of is Postgres, and this also indicates that it's not just events, traditional streams, queues, and things like that. You can be quite flexible and quite custom about how you go about these things. This is just scaling based on the results of a query database. We can see here that we have a trigger, we have a connection string from an environment variable, and we have a specific thing. And this looks like a queue sort of auto processing like query, but you could literally scale it based on comes in from Postgres. If you are interested in this kind of thing, a colleague of mine who's an open source contributor to Postgres and also works on the Citus and Postgres teams at Microsoft since we acquired Citus, Thomas Monroe did a great talk called Queues Postgres. Use Postgres in this fashion, how to be able to scale out queue-like workloads, but also things that require transactions inside of Postgres. And it's actually quite a fun approach, which I thought I mentioned there. Finally, external are two very important scalers because they allow you to scale, to implement your own logic and implement scalers without having to build them into the project. So you basically create a gRPC service which fulfills a specific contract, and you tell KEDA where to hit that service. You can pass in some additional metadata and other things that your service may require. And again, it allows both the polling approach and also the ability to have a streaming service. You have that low latency coming back into the project. And this speaks to KEDA's extensibility. And the next thing that I'd like to cover is how we can implement those. So we have this contract with a gRPC. We have our, this is much like entered it inside of Go itself. Sorry, inside of a native KEDA scaler. You just need a get metrics call. But then we also have this function here called stream as active, which enables you to, or if you have one of these, it's a streaming scaler, and you can build one which is very, very low latency. Which brings me to the next part, the KEDA HTTP add-on. So this was a project that Aaron Schlesinger and including myself at Microsoft, we saw a gap inside of KEDA where we have a lot of folks who want to be able to scale HTTP workloads, and KEDA is great at the event-driven approach, but it really needed to be able, according to HTTP requests coming in. You can kind of Rube Goldberg that by saying, here is your application, it's going to put metrics to Prometheus, and you can scale based on those things, but it's higher latency, and there's some workarounds, and people really often want a native and a solution in that space. And there's a lot of room for optimizations and different approaches to scaling HTTP workloads, which benefit a lot of people. So we announced this in June 2021. It was led by, like I said, a colleague who's in AKS, Aaron Schlesinger, work with quite closely. It reached version 0.30 in January 2022, and we have another release coming up soon. If you want to learn a little bit more, you can see a video, a longer form video we record scaling HTTP workloads, HTTP-based apps using KEDA HTTP at the launch space, and we cover a little bit more there. But one of the key things about KEDA HTTP is that we implemented it using its native extensibility. This was implemented as an external scaler. It sits right there next to KEDA, and it allows you to scale all of these workloads out for HTTP applications. And this is what the scale HTTP looks like inside of KEDA. So we have a scaled object. When you deploy a KEDA HTTP application, you deploy an HTTP scaled object. You don't have to deploy a separate scaled object. This is a sort of simple interface. You provide a host. You have a target pending request. This is how many requests your container should be able to handle. And then we have a target deployment that will be scaled, a service that the traffic will be routed back to, and service will receive the traffic on. So it's a very simple interface. This is an additional concept brought to KEDA, separate to the scaled object, and you don't have to think about that. So this is the architecture. You can see three different areas here. One of them is the parts that are managed by the KEDA HTTP add-on. So it brings a number of extra moving parts, including a scaler, which works with KEDA to actually perform the scaling itself. We have an interceptor where the requests come in. They come in via a service. They hit this interceptor, which can also help scale a workload up from 0. And via the KEDA HTTP And then we also have this HTTP scaled object, and that works in parallel with a backing scaled object inside of KEDA that you don't have to see or manage or deal with. And then, of course, you just, which is scaling your deployment with your service ingress that you bring along. So you need an ingress, you need to route back to the KEDA HTTP service, and you need a service and you need a deployment. This is the architecture. Now,
can I ask a quick question?
Sorry, go ahead. Yes.
Yeah, no, just based on the diagram, like, is it important which type of ingress using, or is like completely independent? Like you can use Istio Gateway or Kubernetes, Nginx, let's say ingress, doesn't matter, right? Because like everything is.
Yes. So this is completely agnostic and composable by design. So by default, we show people how to use the Nginx ingress. You can use anything, and you can actually just you can use a service. You can use whatever is necessary. So the key takeaway from KEDA is it's very focused, composable, and extensible, and designed to be very approachable in that regard. Now, I know we're a little bit short on time, so I have actually a demo for you. So
okay, Aaron, you can take a little bit extra. Aaron, don't worry if you want to take a little bit extra. If people need to drop, we're gonna record until the end. So don't be stressed on the time.
Oh, okay. Thank you very much. Yeah, I'll see if we can go through at least the KEDA demo, and I'll take it from there. Let me just see if I can. So one thing I will say is that all of these demos are available in a repo. So I would love this to be a sandbox through and use a Kubernetes cluster, deploy KEDA to it, and deploy both a KEDA application, a simple blob processing workload, which shows you how to scale in and scale out of the application. And secondly, a HTTP application, which shows you how to do a workload on that front as well. And I can show you just very briefly. I'll switch here. You can see that on my website here. If you go to aka.ms/cloud-native-KEDA, you can see both the repos, the labs, which I'm actually doing the KEDA demo out of, the lab for the KEDA, and walk through the demo for the actual, as well as the slides that I've just been through. But I'll just very quickly go through the
Is it just me who lost Aaron?
No, Aaron, I think we lost you. Can you check your connection with the headset?
Can you hear me now?
Literally, like last 20 seconds, we lost you. So
yeah, that's working.
Oh, so sorry.
Aaron,
okay.
Before we move on, we have a question. Maybe it's better to answer that now. The question is about,
for sure,
you mentioned about using message broker like ActiveMQ, RabbitMQ. Usually, the thing we want to monitor is not the queue length, but is the sustained rate of published message into the queue. So does KEDA have something to support that and to use that information? So
that is
sustained
a
rate
very good
instead
question.
of number of messages.
Yes, I haven't tested that. And all the rest, but I do know that each scaler has its own metrics that you can use, and you can also use a formula to define your desired replicas from that as well. I'm going to right after this and go through. I'm doing a lot recently, more work on the HTTP side of things and some of the other more esoteric scalers. But that's a very good question, and I'd love to chat more about that. And just if people have to drop, if anybody has any questions and they want to reach out to me afterwards or hack on anything, please feel free to go to that URL, and you can drop by the Microsoft open source Discord or reach out to me on Twitter or something like that. I'd love to get on and also introduce you to the project or the HTTP add-on if you have other things that you'd like to maybe contribute to or work on that side of things. That'd be very interesting. Yeah. So this is the first portion of. I don't think we'll get through both of them for sure here, but if we go through, you can land on this GitHub repo, and you'll be able to see that you can just pull down, clone it to your local machine. Say VS Code. Will bootstrap a Kubernetes cluster. You can run KEDA anywhere. This will bootstrap an AKS cluster, both with the cluster with KEDA pre-installed on it. So it'll deploy KEDA onto that cluster for you. So like a sandbox, and it will store it and everything you need to actually run the demo, that kind of thing, and hack on it. This is using Azure Blob storage. KEDA does Azure, GCP, S3, all of those. This will get you up and running in about. You can also run KEDA in Minikube by just running the kube control install from the YAML files. So this takes probably, I've sped this up a little bit for the actual deployment, but you'll see that it deploys in cluster with everything that you need. And then we can see that we've got a cluster deployed. Go into the AKS cluster itself, and you can have a look at the workloads inside of kube control or K9s, but we can see we have a KEDA namespace inside of the cluster. And inside of that cluster, inside of that namespace, we have the KEDA operator and the KEDA metric server. So knowing that we have those two things up and running, we can now go and deploy the main portion of the KEDA app. So we have our resource group. We set a couple of also we what cluster that we're speaking to, just to connect to it or authenticate to it. And then we can run this command, which inside the demo app is inside 0 fold. So you've got a deployment, a scaled object, all the stuff that you need to run, and you can deploy that using customize. We're using this AZAKS invoke command, which was actually used to install KEDA as well as part of the deployment. Because you need to be able to bootstrap stuff or run stuff on a cluster you don't have exposed to the public internet. This is just a quick way of saying, run these commands on my cluster, and it's just deploying those manifests. But for the rest of the demo, we will actually be use AKS get credential that just merges the config into your kube config, so that you're authenticated against the cluster. Then you can use kube control, K9s, etc. And then finally, we will need to for our Azure Blob storage. This is so that our demo application, which is ASW101/go-blob, it's written in Go, can use that secret to connect to the blob storage. There are different ways of connecting to it, but this is just the simplest from a demo perspective. Kind of delete and reapply, because when we first deployed it, and crash back off because it doesn't have that secret. So it's just a little niggle there. But you can see we're deploying a namespace, service account, scaled up, something called trigger authentication, which allows you to thread the authentication required for KEDA to access the blob storage account to monitor the number of blobs inside of that account to be able to run it. How are we for time? All right.
No, you should be good. Don't worry. Please just carry on, because I think this is the biggest value that we're getting from you by showing a demo. You're saving a lot of time for us as well, like to see it visually.
And this is designed to get people up and running. I'd love folks to actually be able to get hands-on with KEDA, whether it's in this or whether it's locally or anything like that. And I find these things are great entry points into open source projects. And we
have a Helm chart.
Our workload. Sorry.
You have a Helm chart for KEDA or as well, or?
Yes, so there is a Helm chart. You can deploy it three ways actually, via the operator hub, via a Helm chart's probably the most popular one. You can install it just via a single kube control command, which is useful in different contexts, and you can install it via its operator, via Operator Hub. And all of those are available in the official docs. So you can see in the namespaces here right now, we have workload called Go Blob. It's a single container that just connects to the blob storage and loops through the blobs and works through them, dumps them to standard out and a couple of things. But it's a good place to just start hacking on blob stuff that might look like it's processing a large number of videos or something like that. And there are various strategies you could use to shard this out. As I said previously, you might have folders. Your external tool might say, I'm going to these files into separate folders, and then you have one file or one blob at the root level for the number of concurrent workers. So you're kind of managing that compute all from just creating blobs using tools that can do all the stuff in bulk. So now if we open my favorite tools so that we can monitor the cluster, and we can go and have a look at our deployment, and we can just go back so we can actually see how many things are running. So if we go into Go Blob, and you can see that I've got, and that is because when I first started this up, it created a container inside my blob storage account, and then also wrote one file into there. So it's running because there's one file at the moment. But otherwise, that would have scaled down to 0. First deployment. But now if we want to test this out, we can go to our storage account. So if we find the storage account in the portal, and this is just the easiest way of getting a few quick files in there. We look at the storage accounts, we look at the, we find the container. So we've got our blob containers right there. And then we have my container. And then we'll see that we have one hello.txt in there, which was written by our Go application. And I just wanted a handful of files in there. A bunch of files from this sample, which is actually the deployment yet manifest, because we don't really care what they are. They're just a bunch of text files. And we'll upload those. And you can see those go straight in there. And we can now go back to canines. And within every 10 seconds, you'll see this scale up and back to the max replica count, which is 5. And then that will immediately be running, and each one of those blob storage account and printing out, in this case, all the blobs, but you could absolutely shard this out, and you could have some logic in there, use a scaled set, or use scaled jobs if they're specifically job-based one-to-one, but this is something that could process a lot of things in parallel. And then if we want to see what it looks like when we have no blobs, if this application was deleting all of those blobs as it was processing them, which it can, there's something you can just uncomment there, it immediately can scale back to 0. And all of this is configurable because I've configured the cooldown time, I've configured the polling interval, I've configured all of this kind of stuff, and it makes it very easy for people to operate. And if we look at the manifest that we use, the KEDA manifest authentication, which is passing through a secret target reference. So it's referencing this key on this secret, which later gets referenced in the KEDA manifest in the scaled object. We can see we have the polling interval, the cooldown count, the target of our scaling, some advanced functionality, which gets passed through to the horizontal pod autoscaler. So one of the things that's interesting, you can restore to the original replica count. Scaling application, or you remove the scaled object, you can say just whatever the replicas were before I started scaling it with KEDA. And then you can also define things like stabilization windows for your horizontal pod autoscaler and things like that. If we go down, you can see that this is an Azure Blob trigger. We could have multiple triggers for Azure Blob or of different kinds scaling a specific workload. We define the blob container name, which is the container that it's monitoring, the blob count for each item that's inside of blob, how many we want, the prefix, so we can use that for sharding, the blob limiter, which is the delimiter is something which can treat your blob storage like a bit like folders, etc. If that's how you want to treat them, and then finally the authentication, which is threaded through from the trigger authentication at the top of it. So this was something that was in KEDA 2. authentication, very flexible. You can use many different authentication types, including lots of different stuff on cluster capabilities, and you can do this at both the deployment level and even the cluster-wide level. So that application. So if you go to the application, we go to ASW101/go blob. This is a template repo you can grab and you can play around with. It's built into a distro list container. It's a Go binary and a distro list container. Huge fan of those. And you can just see that it's really simple. It's just pulling in an SDK, getting it from environment. It's creating a couple of things, and then it's just in a loop, listing, downloading, and deleting blobs. Quick sample use. If you have a work, I want to build I want to process a whole bunch of things. I want to do it in Go. Just use this, and you just add your own logic, and you're immediately processing things with KEDA. So that's the KEDA demo for blob processing inside of on top of AKS, but you can run that anywhere as well. Also have a demo for. Sorry, go ahead.
That looks awesome.
I know we're over time. I do have a second demo, and a second, all the samples and so forth for folks to be able to do the KEDA. Very, very similarly, you can deploy your Go HTTP endpoint, which has some useful endpoints to be able to insert delays and other things to enable you to scale it. Similarly, you can use Hey to send some load to the cluster and see your work down. So it's very much a stub which you can use to build your own scalable applications. And it also shows you very end-to-end how you can go about scaling your application just via HTTP as well. So I know we're short of time at the moment, but I'd love to hear if anybody has any final questions or anything like that. And yeah, so I see Andrew's also shared the akeda.ms/cloud-native-KEDA repo. You've got the source code and the slides as well to be able to do that.
Yeah, so please drop the questions. Aaron, thank you very much. I think the demo was amazing. It worked. I have a question. Like obviously, like looking, Kubernetes has HPA, right? Like a horizontal autoscaling.
Yes.
So this adds another dimension to the thing. So you can pretty much customize. I saw that you can specify min max, right? And you can also specify desired replica. That's kind of new feature for me. So you can, if you specify desired one, then it's going to scale to the desired level, right?
Yes. That comes from is defined by the metrics and the target, and it's a dynamic measure which works out the number of replicas you're looking for based on the metric that's coming in. Of course, the metrics mean lots of different things depending on the source. So you need that sort of customizability, based on that. But that's one thing I think KEDA really does do, is it gives you that extensibility and the flexibility at that level. Decisions up front, and then you could be scaling on one thing today and then swap it out with another scaler tomorrow and be running across multiple clouds next week, and it's very powerful from that perspective.
All right, let's see if we have more questions. Aaron, can you stop sharing? I will just try to. Yeah, I don't know if you're presenting maybe at any other events, or you're planning to present anywhere. Let us know. We're happy to promote, because I think people liked your presentation and the demos, so we'll be happy to share. And yeah, like for our attendees, we are on the tip of hour, so we're going to slowly ramping up if you don't have any questions. So we provided here post-event survey. If you can provide us feedback. Right now we're looking, if you're ready to go to the in-person events. We're also looking for venues, and if you want to help us with anything, we're always looking for help. And then, yeah, like if you can take at least a few more minutes to scan the barcode, or I can put the link in the chat as well so that we have it for people. But I really appreciate everyone's time, and we're gonna try to have some news about in-person events. I think right now for us, our main goal is to find the venues. We have a few speakers already interested in the different cities. I know we're working on that, so let's stay tuned for that. And again, thanks Marino joining our org team, and also like presenting the your Kubecon recap. I think everybody got excited. Hopefully we have more people going to North America this time, and we can all meet together. With that, I want to thank everyone for joining us, and as I said, looking forward for the next event. Thank you.
Thank you
Very
all.
much, Ivan.
All right. Marino, Aaron, nice to meeting you.
Thanks.
New reality.
Yeah, no, I mean,